I am here now with my colleague Reinhard Datschl. He's our expert for fuel cell and electrolyzer, and I'm curious what is new in his area. So, Reinhard, fuel cells, electrolyzer, a challenging topic. Fuel cells are in the meantime already established, and many users are working in this area. How do we support these existing users and make their life more easy when modeling and simulating such systems?
Yeah, hello, Oliver. Thank you for having me here. And we have greatly enhanced CruiseM in making fuel cell simulation more easy for the user to enhance usability by implementing, as we call it, PEM fuel cell system generator. That enables the user with a very few input data, so the cell active area and the number of cells in the stack, to automatically build up a complete PEM fuel cell system comprising the anode and the cathode media supply, comprising the electrical auxiliaries and the load. And that's all based on a generic configuration, and within let me say seconds, the user has got a fuel cell system model configured to his stack performance. He can start off with his parameter variation and studies, and do an analysis of the system performance and BOP component dimensioning, material selection, and so on.
Sounds great. How can I imagine how this really looks like from the usability? What is necessary for the user to really do in the tool?
Yeah, let's have a short look on the PEM fuel cell generator. So you simply open the CruiseM GUI and you start the system generator, and then you simply type in the active area and the number of cells in the stack, and based on a generic configuration in the background, the tool automatically sets up the BOP system, the anode path for the hydrogen supply, the cathode paths for the air supply, and the electrical network that's required to drive the compressor and to deliver the electrical power output to the consumers. The user can interact with the individual components and subsystems by typing in more detailed specific information if available, and is free to access all the BOP components like the ejector, injector, like water separator, or here on the cathode side, the compressor characteristics or the humidifier characteristics can adapt it by the user if required, if necessary. And also the electrical network is pre-configured here with the e-motor for driving the air compressor, and the DC-DC converter and the interface to prescribe the quasi-steady or transient electrical load requested from the fuel cell. And once these especially once the load demand is specified, you're ready to run, and you can directly then look onto the transient dynamic performance of your fuel cell, of your BOP components, and whether that fulfills your needs and requirements, and can start off from this basic configuration then to do your performance optimization loops.
Looks great. Is this fixed to specific configuration, or what does this mean for the modeling flexibility at the end?
Well, right now we have a generic baseline configuration available, utilizing an electrically assisted air compressor, utilizing an anode recirculation loop with the ejector injector. And we're currently working on different generic configurations with the electrical turbocharger, without external humidification, anode loop without anode recirculation. So the next releases will bring further configurations the user can choose among for his work.
Great. So we see processes going on. When we now look from the PEM fuel cell, also technology-wise, it's developing. How you are treating in this release new technologies? What is coming in respect to this?
Well, on the fire side, we have been extending our low temperature PEM fuel cell module towards high temperature PEM technology. So that's a technology that offers quite promising future potential. It's operated in the range of 130 to 180 degrees C, is less sensitive to the hydrogen purity, and due to the fact that there's no liquid water produced and transported in the system, the BOP system is kept more simple. And we have implemented that technology and with the first release we provided to our users in FireM. And it's based, so the membrane technology in this case is based on PBI membrane technologies, and further membrane materials will follow in the next releases.
Yeah, sounds very interesting. Maybe a question for our non-expert. If you see low temperature, high temperature, in which area do you expect that the high temperature fuel cell will first establish and grow market?
Well, the heavy duty applications will be the ones where the high temperature PEM fuel cell is most suitable to. So that can be heavy duty road transport, that can be ship application, railway application, and even aeronautic applications, where this high temperature PEM will be a potential solution for the future.
Yeah, when we are talking about this area, we see not only fuel cell, but electrolyzer business. So when we are talking about hydrogen society, there is a requirement to produce hydrogen on a larger scale. So what is new in this area of electrolyzers?
Yeah, we have been active in electrolyzer simulation now for quite some time. We're constantly extending our portfolio there, and with the latest release, we're now offering the anion exchange membrane electrolyzer technology in FireM. That's a electrolyzer type that is close to the classical alkaline electrolyzer, but instead of using a diaphragm, is using an anion exchange membrane. And this is now fully available and supported by FireM with also the necessary material properties in the property database. And it's especially advantages here in this context is that Fire offers a full multi-fluid based multi-phase model. So we do solve the full set of Navier-Stokes equation for the liquid water, for the hydrogen gas bubbles, and for the oxygen. And with this multi-fluid treatment, we can achieve a very high level of accuracy with respect to the phase change processes, with respect to the heat and mass transfer between the different phases on the anode and the cathode side.
Do you focus here with this anion exchange membrane electrolyzer specific on the cell development, or can this also be used for stack development? Who is the target group who can benefit from this?
Yeah, the target group are the cell and stack manufacturers or developers on one side, but also the material suppliers or the subcomponent suppliers, the suppliers of the membrane technology, the suppliers of the gas diffusion layer, or the other hardware parts in the cell, in the stack, are the prime target customers for the FireM simulation solution in this area.
Yeah, we heard many interesting things. Are there any other topics which are also new? What else can our people expect from this release?
Well, there are a bunch of other new stuff in improvements, extensions of existing functionalities with respect to the model fidelity on one side, but also with respect to simulation time reduction, for instance, there, for instance, regarding model fidelity on the Cruise M side, we are supporting now the metal sheet plate, bipolar plates, where the user simply types in the channel cross section and channel dimensions, and the Cruise M automatically builds up the cell, metal sheet based cell with the anode and cathode channels and the cooling channels in there. And these you can then, in the usual manner, you then can staple to build up your entire stack in Cruise M in a very fast and easy manner.
That sounds really great. So thank you, Reinhard, for this introduction and this update, what's new in the area of fuel cell and electrolyzers.
Yeah,
thanks a lot for your time.
Thank you. My pleasure.